Good morning, everybody. Welcome back to chemistry. This morning we're going to be talking about PEN. What is PEN? PEN stands for protons, electrons, and neutrons. Okay? Now, what you're looking at here is carbon. This is the way you would see carbon written on the periodic table. Now, in the past, teachers would require their students to memorize the entire periodic table, but that's not what I'm going to do because to me that doesn't make sense. What I'm going to do is teach you how to use the periodic table, okay? Whenever you look at the periodic table, I want you to look at it as if it's a toolbox because it does everything when we're talking about chemistry, okay? So what I'm going to do is break down what this says from the periodic table. Now, the first thing we're going to look at is we have the name of the element carbon. We have the symbol of the element carbon. And then we have these two numbers right here. So I'm going to explain these two numbers. Let's start with the top number first. Okay? This top number is what we call the atomic number. Now, what does the atomic number tell us? Well, it tells us two things. First of all, it tells us the number of protons. Okay? Now, let's talk about protons real quick. Protons characterize the element, okay? Protons characterize the element. Well, what do I mean by characterize the element? Well, it tells you exactly what the element is. If you have 6 carbons, it doesn't matter where you go on Earth. In fact, you can go to another planet. If you find an element that has 6 protons, it can only be one thing, carbon. Okay? If it had 5 protons, that means you have boron. Or if you had 7 protons, that means you have nitrogen. So protons tell you exactly what the element is. So protons are very important. Characterizes the element. The next thing we're going to do is talk about 6 also tells us the number of electrons in a neutral atom. Okay? Well, what do I mean by neutral atom? Well, the overall net charge is kind of like a magnet here. You know how magnets have a positive and negative charge? Well, it's kind of similar. It's not the same thing. Well, normally, let me bring another piece of paper here. Okay? Protons have a positive charge and electrons have a negative charge. So when the number of electrons matches the number of protons, you have an overall net charge of 0 because they cancel each other out, right? So let's look at carbon, for example. Carbon has 6 positive protons. And if we look at that atomic number, because we just said that 6 is also should be the number of electrons, we have 6 negative electrons. So all the positives cancels out all the negatives. We ended up with a net charge of 0. Whenever you're looking at the periodic table, you're going to notice that atomic number, since it tells you protons and electrons, that means all the elements are neutral because the protons matches the electrons. Well, we know the number of protons can't change because that characterizes the elements. But the number of electrons can change. Okay? So, I have this little thing that I like to write. Okay? It's this. Positive means you lost electrons. Negative means you gained electrons. But you're probably thinking to me, wait, that don't make sense. Positive means you lost and negative means you gain? Yeah, because we're not looking at this from a mathematical point of view. We're looking at this from a charge point of view. Okay? So let's analyze what we got here. Okay, let's go back here. Well, let's say we lost an electron. We're going to look at losing an electron here. Okay? Protons stay the same. I have 6 protons. And instead of having 6 electrons, I only have 5 electrons, right? So when all these 5 electrons cancels out 5 protons, you're left with 1 extra proton, 1 extra positive charge, a positive 1, right? Because we're talking about negatives. 5 negatives cancels out 5 positives, so that leaves me with 1 positive left, a positive 1. So let's say we gained an electron. I still have 6 protons. Normally I'd have 6 electrons, but now I have 7 electrons, right? Well, let's look. When these all cancels out, what's left? Well, 6 protons are going to cancel out 6 electrons, so that leaves me with 1 electron left, so that's a negative 1 charge, right? That's why when we lose electrons, we take on a positive charge because less protons are getting canceled out, charges. And when we gain electrons, we get more negative because we have more negatives than positives. We're talking about charges here. But to keep it simple, we'll just look at it like this. Positive means we lost electrons. Negative means we gained electrons. Okay? Now, we got one more particle we got to talk about. Neutrons, right here. Okay? Well, this top number, atomic number, tells us the number of protons. It also tells us the number of electrons it's supposed to have, right, in a neutral atom. Well, how do we find neutrons? Well, let's go to this number right here. This is what we call the atomic mass. Well, what makes up the mass of an element or an atom? Well, we say electrons. Even though electrons do have mass, they're so small that their masses don't matter. Okay? So what makes up the bulk of the mass of the atom is the nucleus. Well, what do we find in the nucleus of an atom? We find 2 particles in the nucleus of an atom. We find protons and we find neutrons. Right there. Protons and neutrons. That's what we find in the nucleus, and that's what makes up the mass. Well, how do we find neutrons? Well, do we know the number of protons? Yeah, we know the number of protons. So if protons plus neutrons makes up the mass, all you got to do is take out the number of protons, and that will tell you the number of neutrons. Okay? So let's do that real quick. So we know if we take the atomic mass and we subtract out the atomic number, that equals neutrons. Okay? So let's do that real quick. Well, what's my atomic mass? 12. What's my atomic number? 6. Well, 12 minus 6 is 6 neutrons. That simple. Okay? Go this minus that number. This minus that number gives you neutrons. Really simple. Okay? Now, protons can't change because they characterize the element. Electrons can change, and when they do change, we form what we call charges. Okay? We form charges. Well, can neutrons change? Yes, right? When neutrons change, we call those, let me move this up a bit, isotopes. That's a fancy word for saying changing number of neutrons. So whenever you hear that word isotope, just start thinking about the mass because you got to calculate the number of neutrons. That's it. When neutrons change, that means isotopes, a different number of neutrons. So all you're going to be doing is calculating neutrons. Well, because neutrons are the thing that's important, whenever you're dealing with isotopes, they like to write it a little different. Okay? You'll get your symbol here, and then they'll switch it. They'll put 12 up top and 6 at the bottom. See how it's different from the periodic table? Periodic table puts the atomic number first and then the mass. When we're talking about isotopes, they put the mass first and then they put the atomic number. Well, why is that? Well, because it's the mass that's important. That's what we're looking at here, right? And it makes it easier to calculate. 12 minus 6 is 6 neutrons, right? Well, let's look at isotopes here. Another way they would write this if you're dealing with isotopes would be 13, 6. Well, it's still carbon, right? The atomic number hasn't changed. It's still 6, so we're still dealing with carbon here. What's different? Well, the mass is different, right? That means we're dealing with isotopes here. So let's do a quick calculation. Well, if I do 12 minus 6, that tells me I got 6 neutrons, right? This guy. Well, if I go 13 minus 6, that tells me I got 7 neutrons. So when we're talking about isotopes, all you're doing is recalculating the number of neutrons. That they're telling you the neutrons are different, okay? Now, one last example here. We're going to look at this guy right here. What if they write this? Carbon 14, 6 plus 2. Oh, wow, there's a lot of stuff going on here, right? Well, it's still carbon, right? Protons don't change. Right? Well, look, the mass is different. So whenever you see a different mass, automatically start thinking isotopes. The number of neutrons is different. Okay? So let's do our calculation real quick. 14 minus 6 is what? That tells me I have 8 neutrons, right? Well, let's look at this 6 here. I know I still have 6 protons, right? 6 neutrons and 6 protons. Well, what's this plus 2 mean? Well, that plus 2 means we're dealing with a charge. And when we're looking at charges, what are we looking at here? Electrons, right? So let's look. Normally, this number tells me the number of protons and electrons. Well, normally, I'm supposed to have 6 electrons, normally, right? I'm normally supposed to have 6 electrons. But what does this plus 2 tells me? This plus means what? You lost electrons. Well, how many electrons did you lose? You lost 2 electrons. Well, if I lost 2 electrons minus 2, that tells me what? That you have 4 electrons. So it's easy to calculate everything if you know how to use the periodic table and you know what the atomic number means, right? If you know what the atomic number means, that tells you protons and electrons. Electrons can change. Positive means you lost electrons. Negative means you gained electrons. The atomic mass is made up of protons and neutrons, right? And the number of neutrons can change. We call those isotopes. So whenever you get something like this, you should be able to calculate everything because you know how. Any questions, guys? Well, that's PEN, protons, electrons, and neutrons, and I hope this helps you with your calculations in the future.